Hello everybody, this is Unit 2, Day 2. Okay, this is the area and volume unit. Before we talk about volume, we have to talk about area, and might as well talk about perimeter. Okay, just throw that in there as well, right? You got to make sure you know the difference between the two. Okay, so we're going to be talking about the area and perimeter of a parallelogram. So first, let's talk about some important things to know about parallelograms, right? First important thing to know is, what is a parallelogram, right? Well, it's a quadrilateral, which means it has four sides, in which both pairs of opposite sides are parallel. Which means, if you look in this picture here, I see two arrows over here, two arrows on that side, which means those two sides are parallel. I see one arrow over here, one on the other side, which lets me know those two sides are parallel. And same thing in this frame over here. Okay? It says opposite pairs, both pairs of opposite sides are parallel. Right. It's also important to point out it can be shown that opposite sides of a parallelogram must be congruent. So that means this side is congruent to that side is congruent to that side. And same thing with the other shape. Okay. Notice I use either two dashes or one to kind of signify that the opposite sides are congruent, but not all four. Okay. We haven't proved anything yet, and so unless they tell us that all four sides are congruent, or we've proven it somehow, okay, we just know that parallelograms have opposite sides that are congruent, okay? So, it's also important to point out that opposite angles are congruent. So that means this angle is congruent to this angle, and then this angle is congruent to that angle. Same thing on the other side, okay? All right. And finally, consecutive angles are supplementary. Right? What are consecutive angles? Okay, consecutive angles come one after another. Remember, they fall on the same side as the transversal. Okay, but in between the two lines. Okay, so if I had 1, 2, 3, and 4, right, our consecutive angles would be 1 and 2, 3 and 4, all right? And then if I had these parallel lines going this way, well, then my consecutive angles would be 2 and 3 and 1, 4. Okay? So add those measures up. What do you get? You get 180 degrees. Okay? So that's what it means to be supplementary. Remember, you add the two measures up, they add up to 180 degrees. Okay? And the consecutive means that they just fall on the same line, right? So measure of angle 1 plus the measure of angle 4 will equal 180. Okay, the measure of angle 4 plus the measure of angle 3 will equal 180. Okay, so on and so forth. All right, so let's talk about the area, because we're not going to be so focused on angle measures, but that will reappear when we talk about parallelograms again, so just keep that in mind. All right, when we have to prove we have to prove something's a parallelogram. So anyway, just keep that in mind about consecutive angles or supplementary. But we're focused on the area of the parallelogram. So let's talk about how to find the area. To find the area of a parallelogram, right, if you notice, it's the same formula as your squares and your rectangles, right? Base times height, where base is the length of one of the base and h is your height. Okay? But if you look in the diagram down below here, you'll notice that our height is not these diagonals. Okay? A lot of students will fall for that. Okay, what they'll do is they'll put a number over here, right? And they'll have a number for the base. Let's say the base is 10, and they'll have a number for the height. Let's say the height is 4. Okay, and what students will do is they'll go, oh, area, base times height, 10 times 5, 50 units squared. Okay, wrong. Okay, this is not our height here. This is our diagonal, right? This does not determine the height of the parallelogram. The height is determined by, the height is determined by a perpendicular line created from one of the vertices, and it goes down to the base. It's perpendicular with this base. All right, so if I extended the base out here, this height would be perpendicular to that line. All right. Also, sometimes you can see the height be represented on the inside, of the parallelogram. And again, you'll notice that it creates a right triangle in both cases. All right, we need a perpendicular line, which means creates a 90-degree angle with our base. All right, and notice in both cases it's coming from one of our vertices, right? We're either coming from this vertice here or this vertice here. All right, now I also want to point out, and it's worthy to point out, that if I had this triangle right here, right? So here's our height. And I took this triangle and I chopped it off and I slapped it right on the other side of this parallelogram. Okay, so let me erase that now. And look what we have here. We have a rectangle. All right, and so really, and remember our height, again, was represented by this line right here. And so if our h was 4 and our base is 10, all right, really what we're doing is we're finding the area of a rectangle, right? Which is base times height, so 10 times 4, 40 units squared. Okay, so really when we're finding the area of a parallelogram, we're still really only finding the area of a rectangle, right? Except you got to remember our height, again, is represented by that perpendicular line created either on the outside or the inside of our parallelogram. Now, if we wanted to find the perimeter, okay, perimeter is the same as finding the perimeter of rectangles and squares, right? So we would go 5 plus 5, which is 10, 10 plus 10, which is 20, and we would get 30 units, not units squared, okay? And so in this case, we could find our perimeter as long as they give us the length of one of those diagonals, right? Sometimes we're not going to be able to find the perimeter based off of what information they give us, all right? And so you'll see what I mean when I get down to the problems below. Now, in this picture right here, hopefully we don't see this one represented like this too often, okay? This is kind of a messy looking parallelogram. Maybe in one like this, they might actually even have it like this as well, right? Nice perpendicular line up from here. Okay, you might also see a height like that. All right. Typically, they look a lot like this. This is what we usually see them represented as, but sometimes they might have them like this. So just be aware that our height, again, is that perpendicular line created from the vertice down to our base. In this case, the baseline extended. All right, so, and then the perimeter of a parallelogram is the sum of the lengths of its four sides. All right, so let's get down to the nitty-gritty, and let's start finding the area and perimeter of these parallelograms. All right, so here's our first parallelogram. Our height is not 62, it's 54 meters. All right, our base, 71 meters. All right, so to find our area, base times height, which is 71 times 54, which is, I don't know if you guys know that off the top of your head, but I don't. 71 times 54, and I get 3834. Now they actually gave us a unit here, right? We have meters, so we would go meters squared. And that's the area of our parallelogram. All right, how about the perimeter? Well, the perimeter is going to be 62 times 2 plus 71 times 2. And so 62 times 2 plus 71 times 2, and I get 266 meters. Okay? And so that's how we find the area in the perimeter of that particular parallelogram. Let's go down to the one below. So in this guy, all right, let's find the area first. So the area, well, let's talk about what our height is. Our height is 5 centimeters. Our base is 1.8 centimeters. And so we go base times height, which is 1.8 times 5, which gives me Oh, a nice even number. 9 centimeters squared, right? We have 9 cubic, 9 1x1 cubic meter boxes inside this parallelogram, which is kind of neat. That doesn't look like we would have a nice number like that, but we do, okay? So 9 centimeters squared, right? Or 9 cubic meters, right? Or our 1x1 boxes are 1 centimeter by 1 centimeter. All right, just remember that when we're finding the area, that's what we're doing. We're finding how many 1x1 boxes fit inside these shapes. Now, for the perimeter, though, all right, we don't have enough information to find our perimeter. Okay? They don't tell us what our slant is, and there's no way of us knowing what this length is right here. Okay? We could find it, or if we had it on like a coordinate graph, right? If we had some actual plot points and stuff, but because we don't know what that length is, all right, we cannot find the perimeter. So we're going to just say perimeter, not enough info, right? We can't just guess what that length is right here. If we did know what that length is, let's say it was 1, right? Well, then we could use Pythagoreans, right? Okay, because we have a right triangle here. But again, we don't have that information, and so therefore we cannot find our perimeter. All right, let's go down here. Now here, we will definitely be able to find our perimeter and our area. All right, so let's find the area first. Let's talk about what our height is. Well, our height, is 3, right? We got this perpendicular line coming up from our vertice to the other base, right? The top of the parallelogram, so that our height is 3. Our base, represented by CD down there, is also 3 units. And so our area is 3 times 3, which is 9 units squared. Let me write it off here. Okay, which means we have 9 1x1 boxes inside our parallelogram, right? Doesn't quite look like it, but if we were to kind of piece those together like a puzzle, we would get 9 units. Okay? Also, it's important to point out that if we were to take this triangle here, right? And attach it, so cut it off here and reattach it on the other side of our parallelogram, right? We would get a square. Right, 3 by 3 square. And so how many 1x1 squares do we see inside this square here? We see 9 units, okay? So it's a little easier to see once I take that triangle and move it over to the other side, right? Let me just erase it here so you can see it a little better. Come on. There we go. All right, so there's our 9 by 9 square. And as you can see, we have 3 of those 1x1 boxes inside of our square, okay? So now let's talk about the perimeter. All right, now in this case, okay, we can find our perimeter. All right, now think about it. All right, this length right here is 2 units, right? Okay, and this guy is 3 right here. So in order to find our perimeter, right, we would have to use Pythagorean's theorem. Pythagorean's theorem. Okay, so we would go, now remember, this side opposite our right angle, okay, is always our hypotenuse, right, or our C value. Okay, so you can always screw up your A's and B's, but you cannot screw up that Z value, or that C value. Okay, so I got 3 squared plus 2 squared equals C squared, so this is 9 plus 4 equals C squared. So we get 13 equals C squared, take the square root, so C is equal to the square root of 13. All right, which means that this length over here, square root of 13, and this right here, square root of 13. So let's add those all up. Now, it doesn't say anything in the directions about leaving it in radical form here. So I'm just going to add those both up. So I'm going to go 3 plus square root 13 plus square root 13. And I get our perimeter is 13.2111025. Okay? And there is our perimeter. Okay. Let's go down to our last problem here. All right, so in this one, okay, they don't give us the height, right, so we got to come up with this height on our own. So I'm going to start at B, and I'm going to go up to the top here. Actually, no, I'm going to do it. We did that in the last example, okay? I'm going to extend AC out. And I'll draw a perpendicular line here. There we go. Okay? The height's still the same, right? In both cases, you would see our height is just 3 units. Okay? Now, we need to find our base. So our base, this is a nice picture here, right? So I can just go 1, 2, 3, 4, 5. So our base is 5 units. So our area is 5 times 3, which is 15 units squared. All right, and again, let me erase this guy right here. All right, so if I were to take this triangle right here, I were to chop it off, put it on the other side. So it's over here now. I'm going to erase this guy here. Ooh, that worked out pretty good, huh? All right, so now, okay, I have a rectangle, which as you can see, is a 5 by 3. And how many 1 by 1 squares you find in here? 15. All right, so it's a lot easier to see what these areas are when you kind of take that part of that parallelogram and fix it so you have either a square or a rectangle. So as you can see, how many square units? 15. Okay, let's erase that out of there. All right, now let's talk about the perimeter. Perimeter, all right, well, if this is 5, and that's 5, that's 5, that's 5. Our perimeter is just 5 times 4, which is 20 units. All right. It's also worthy to point out that this would be an example of a equilateral polygon, right? It has all congruent sides, right? Each side has the same measure. Okay? Which means it is a equilateral polygon. All sides are congruent. Okay, for homework, you got these 4 problems. So I want you to find the area for these 3 parallelograms, and I want you to find the area and perimeter for each of these parallelograms down below.